In this video, we're going to learn how to use the BME280 Air Temperature, Relative Humidity and Pressure Sensor. This sensor is a special type of sensor that connects to the JackBord's I2C port, which is on port D. To use the BME280, you're going to need the following: your JackBord, a BME280 sensor, and 4 female-to-female hookup wires. Firstly, let's learn about the I2C port. On your JackBord, the I2C port is located on port D. This is the blue port underneath the JackBord logo. All I2C ports have 4 pins. The first one is some kind of power pin. This is where the power to the device is supplied. The device's power supply pin will either connect to the JackBord's 5-volt power pin or 3-volt power pin. This depends on how much power the device needs. The next pin is the device's ground pin. This is often indicated by the GND letters. The ground pin connects to the JackBord's ground pin. These 2 pins are the power supply pins for the device. After that, we have the 2 pins that transfer the data. The first one of these is the SDA pin, which stands for Serial Data Pin. This pin actually carries the data between the JackBord and the I2C device. And lastly, we have the SCL, or Serial Clock pin. This pin's job is to tell the JackBord and the I2C device how fast they should communicate with each other. The SDA pin from the device will always connect to the SDA pin on the JackBord. And likewise, the SCL pin on the device will always connect to the SCL pin on the JackBord. The first thing we're going to do is attach the wires that we need to the BME280. Once they're connected, we'll attach them to the JackBord. The end result will look like this. If you're confident and know what you're doing, just try wiring it up now. If you're not so confident, or this is the first time you've done it, follow these instructions. The first thing we need to do is to decide which wires are going to do which job. In our case, the red wire will be the positive power supply, the brown wire will be ground, the blue wire will be the SDA line, and the orange wire will be the SCL line. Looking at the BME280, we can see that VIN is at the top, ground is next, followed by the SCL and SDA pins. First, we're going to connect the ground wire to the ground pin. Now the ground wire is the brown wire. Connect it like this. Now take the red jumper wire and attach it to the VIN pin as shown in the diagram. We now have the 2 power supply wires connected, that is the power line and ground line. Next, take the blue wire and attach it to the SDA pin on the BME280. Now take the orange wire and connect it to the SCL pin. Remember that you may well be using different colored wires, and this is fine. The main thing is that you know what each one does. When you're done, you should have your 4 hookup wires connected to the module. Next, we need to take the 4 hookup wires that we attached to the BME280 and connect them to the JackBord. Remember, the JackBord's I2C port is on port D, which is the blue port on the bottom. We will start connecting the BME280 to the JackBord by first of all attaching the ground pin, followed by the data pins, and lastly we'll attach the power pin. But make sure before you start that your JackBord is turned off. Take the brown wire and connect it into the ground pin on port D. Take the blue wire and connect it to the SDA pin. Then take the orange wire and connect it to the SCL pin. And finally, take the red power wire and connect it to the 3-volt power supply pin on the JackBord's port D. If all has gone well, your connection should look something like this. But remember, you might have used different colored wires. So make sure that your connections match those shown in the table. Now that we have the sensor connected to the JackBord, the next thing we need to do is turn on the power to the JackBord and log into your dashboard account. Once in your dashboard account, click on the command link and go to the command page. Turn on the JackBord's I2C system by typing in the I2C on command and press enter. Next, we need to tell the JackBord to go and look for some devices on the I2C bus. To do this, type in the F2C command and press enter. The JackBord will find the sensor on the I2C bus and then display the various readings from it as shown in the screen. Here it's showing us the air temperature, relative humidity and pressure readings from the BME280 sensor. The temperature is in degrees Celsius, the relative humidity is in percentage from 0 to 100%, and the pressure is in millibars. Now that we have the sensor running, you can view readings from it using the GT command. Notice in this case that the pressure reading is very high at 1334.10. This reading is incorrect, and we know this because by checking at the local weather station, we find that the actual pressure is 1000 millibars. This difference is called an offset. In our case, it is 334.10. This means that our sensor has an error of 334.10, and we need a way for the JackBord to apply this correction so that the readings we get are correct. This is done using a command called scgoff, which stands for Set Channel Gradient and Offset. For this command, we need to know the channel, the gradient, and the offset to use. We can get the channel by looking at the left-hand column of the GT command. Next to the pressure entry, we see the number 28. That is the channel. For the gradient, we'll use a value of 1 because the gradient is okay. And finally, for the offset, we will use 334.1. Thus, our final command looks like this: scgoff space 28 space 1 space 334.10. Type the command into the command prompt and press enter. The JackBord is now showing that for channel 28 the gradient is 1.000 and the offset is now 334.10. Now, if we run the GT command again, you can see that the value has fallen to 992.67, which is much closer to the value we should have got. Finally, if you go to the live page and blow gently on the sensor, you'll be able to see the values change. For more information, visit www.jackbord.org.